we learned from last class was a step constructing the confidence level. It's so blurry. I need to adjust a little bit. Okay, good. Constructing a confidence interval. Sigma is unknown. Okay, now the first things you guys need to notice that is normally distributed. The sample size is greater than equal to 30. Second one, you need to find what? N x bar S 3. Identify the TC, okay, TC through what? Through table 5. Or TC through the DF equals N minus 1, table 5. Okay, table 5. 4, find the E. E equals TC is square root of N. 5, find the mu, that is x bar minus E, x bar plus E. Okay, so basically we have 5 steps. The idea is going to be very simple. You find the TC and S, you're going to get the E. After you get the E, you can find the confidence interval after you know the x bar. Okay, so now we're gonna take a look another example. You randomly select 36 cars of the same model that was sold at a car dealership. And determine the number of days each car sat on the dealership. On the dealership or dealerships lot before it was sold. The sample mean is 9.75 days with sample standard deviation of 2.39 days. Construct a 99% confidence interval for the population mean number of days. The car model sets on the dealership's lot. Okay, so let's take a look at this province. So for this province, we know, follow the steps. We know that is there's a claim that is normally distributed. However, we can see they have sample size that is 36. So we can use the above steps to calculate the confidence interval. Okay, confidence interval. And now we just follow the steps, right? Follow the steps. So the first one, we know the n is 36, right? That is greater than or equal to 30. And the second step, we're going to find x bar. And the sample mean is what? 9.75, right? 9.75. And the sample standard deviation is what? 2.39. 2.39. All right, very straightforward. Now 3. In order to find the TC, we needed to know the C and the DF, right? So C confidence level is 99. So it should be a 0.99. And the DF is n minus 1, should be 36 minus 1, 35, right? And use these two parameters. Use these two parameters to find the TC, 35 and 99. You're going to get 2.724, right? Okay, good job. 2.724. Okay, and now, so fourth step, calculate the margin of error. Okay. So we have TC2, plug in everything. S is 2.39. Square root of n. N is 36. And this guy will boils down to 1.09. And the fifth step, left endpoint. X bar minus E, that is 9.75 minus 1.09. X bar plus E, okay. The right endpoint, sorry. So we have a confidence interval that is mu greater than 8.66, 10.84, 84. Okay. Now I'm gonna give you guys an example. Later you guys try it. Later you guys try it. Okay. So now I change the confidence level. I construct 90% confidence level. Confidence interval. Sorry. Blah 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 blah. Try it by yourself. Follow these 5 steps. Okay, follow these 5 steps. Okay, now let me write down the answer on board. Follow these steps. The first two steps should be the same. Okay, the only difference starts with the second. Starts with the third step. The same, right? And the third step gonna be a 90%, 0.9, and the df equals 35, right? And the TC gonna be what? What's your TC? 1.690. Good job. Okay. Use the C and the df. Okay. C is 0.9. It's here, right? Second column. And C is 35. Right? It's 1.690. And fourth step, plug in the formula. Square root of 36. And you're gonna get the number is roughly 0.667, right? 0.67, right? Yeah, it's okay. 690 equals 1.69, right? Because the same thing. Find the left endpoint x bar minus e gonna be 9.75 minus this guy gonna give you 9.08. The right endpoint x bar plus e are gonna be 10.42. Okay, so we have the interval is between these two numbers. Okay, that's it. That's it. Let me give you guys the summary for the section 6.1 and 6.2. Okay, I'm gonna give you guys a diagram how to use these formulas. Okay, let's take a look. The first box we're gonna have is the population normally distributed, or is n is greater than or equal to 30. If it's no, you can't use the standard normal distribution or the t-distribution. Okay, if yes, then we have two scenarios based on sigma is known or unknown? If the answer is yes, then we have used the standard normal distribution with E equals ZC sigma divided by square root of n. Okay, if it's no, then use the t distribution with the E equals what? Equals TC and n minus 1 degrees of freedom. Okay, so basically in chapter 6, we address two important problems. For the chapter 6.1, we address the sigma is already known. It's a known. Okay, then we can use this formula. E equals ZC times sigma divided by square root of n. And for the chapter 6.2, that's what we learned from this class in the last class. If sigma is unknown, then we're going to use this formula. Okay, use this formula. We use the sample standard deviation instead of population standard normal standard deviation. Okay, and of course we use the t distribution instead of normal distribution ZC. Okay, so you can see the difference between these two. It depends on sigma is known or unknown. Okay, unknown. That's it. That's everything for this course.